Good morning, CSEC scholars. Welcome. We're having a live algebra class, and this morning we're going to be looking at solving simultaneous equations, and the method that we're using is the method of elimination. So the last algebra class that we did during this period, we solved simultaneous equations using the method of substitution. So if you're interested in that method, be sure to check out that video. It's already posted on the channel, I think about 2 weeks ago. And you need to know both methods, right? So this morning, we're looking at the elimination method. So I always tell my scholars, when you're doing math, you must look keenly at the terms that are used, and you must understand the meaning of the terms. So in other words, the language of the math. When you understand the language of the math, it will better help you to understand the concept. So when we were doing the substitution method, I asked you to look at the word substitution. What does it mean? And we said that substitution means to put one thing in place of another. And you realize that with that method, we selected one of the variables, usually the one that had a coefficient of 1 or -1, and we transposed to make that variable the subject of the equation, and then we substituted that value into the other equation. So we put that value in place of the variable. For the elimination method, if you look for the word eliminate, it means to get rid of, to cancel out. And so this method is involved with canceling out one of the variables, finding a way to get rid of one of the variables, so as to make us able to focus on the other variable and solve it, and then we go back for the first one that we put aside. So that's why we call it the elimination method. We eliminate one of the variables, whether the x or the y, focus on the remaining one, solve it, and then we go back for the other one. So that's what we're going to be doing this morning. And remember, you really can use either one of the methods. I prefer the substitution method when at least one of the variables has a coefficient of 1 or -1. It's easier that way to transpose and plug in those values without having to run into fractions. But you can. It's doable. It can be done. But, it's always better to choose the easiest route, especially when time is a constraint, as in an exam. Sometimes, though, you are specifically asked to use a particular method, and then, if that is the case, you have to do that method. Remember also that we have solved simultaneous equations using the matrices method as well as the graphical method. If you're unfamiliar with those methods, again, just go to the CSEC playlist, go on the channel Vibrant Authentic Living, and search for solving simultaneous equations, the graphical method, matrices method, substitution method, elimination method. So we have done all of those. So let's go now. So we have an equation on the screen, and this is our first set of equations, rather. And remember, we said the reason why we call them solving simultaneous equations, the word simultaneous means occurring at the same time. And what we're doing is we have two equations with two variables, and we're solving them at the same time. We're solving the two equations at the same time, and we're solving for the two different variables at the same time. Now, what I like to do, so this is our original pair of equations. What I like to do always is to number them. So I'll have equation 1 and equation 2. Now, in order to eliminate, sorry, in order to eliminate the one of the variables, we want to make sure that we want to make sure that we get the same coefficient, or at least the coefficients that have them, they might have a different sign, but the digit itself is the same. So for example, if we have 8x and 8x lining up, or if we have a negative 8x and 8x lining up, we can eliminate them by either adding or subtracting. So the equations, I think all the pairs of equations, hold on, let me double check something. What I'm going to do, I had already had some equations set up, but what I'm going to do is I'm going to adjust at least two of them so that we already have the same variables, and I'll show you that you can avoid one of the steps. So just give me a second to just change those, because I'd already prepared some all right, so what this would give. So I'm going to show you that when we already have the same variables, we can go ahead and do a particular thing. All right, so all right, so let's see, let's do that. So let's go with this one now. So what we're going to do is you can choose whether you're going to work with the x variable or the y variable. You choose. You're going to eventually end up with the same answer, or you should. So when you choose which of the pairs you're going to work with, you're going to look at the coefficients. So in this case, if I'm going to work with the x's, I would multiply equation 1 by the 5, and I'd multiply equation 2 by the 6. Some teachers would say multiply equation 1 by -5 and equation 2 by 6. For me, that part of it doesn't matter, because we're still going to need to look at the signs and decide whether we're going to add or subtract. So I'm just saying work with the actual digit itself, right? So we're multiplying equation 1 by 5 and equation 2 by 6. Or if we choose to work with the y's, we would multiply equation 1 by 1 and equation 2 by 8. So you're multiplying each equation by the coefficient of the opposite variable. So I'm going to work with the y's first. So I'm multiplying equation 1 by 1, which is the coefficient of the other y. And I'm multiplying equation 2 by 8. So that's going to give me two new equations. So multiplying all of this by 1, it will give me the same thing. Multiplying by 1 gives the same thing. And this is going to give me equation 3. Multiplying equation 2 by 8, sorry, is going to give me negative 40x plus 8y. And 8 times negative 13, 8 threes, 24, 8 ones, 8 and 2. So that's our negative 104. And that's equation 4. So what I do now is I look at them, and this process will give me the same coefficient. Or if not exactly the same, at least the only difference would be the sign in front. If they are both positive, we're going to subtract the equations to eliminate the variable. If one is positive and one is negative, we have to add them in order to eliminate the variable. So since we have two positive 8s, we're going to subtract. So I'm going to subtract equation 4 from 3. Subtract equation 4 from equation 3. And when I do that, I'm going to have 6x minus negative 40x, which is 46x. The 8y minus 8y would eliminate the y, which is our objective. And 12 minus negative 104 would be positive 116. So let me see, 116. All right, so let me retrace to see what I did wrong. All right, so let me just quickly retrace. So we have 6 1s, 6 8s, and negative 12 times 1, 8 5s, 40, 8 1s, 8, 13 times 8, 104. And oh, it's a negative 12. Okay. So I was saying 12, but it's a negative 12. So negative 12 minus negative 108, which is the same as negative 12 plus 104, sorry. And that's going to give 92. So x would be 92 divided by 46, which is 2. So what happened now? We have found what x is. But remember, we had two variables. So it's not just to find x, we also need to find y. So what we're going to do now is to plug in this value of x in one of the equations. And we're going to get the y value. So 6x plus 8y is equal to negative 12. So 6 times 2 plus 8y is negative 12. So this is just the basic steps now of algebra. So 12 plus 8y gives negative 12. So 8y is equal to negative 12 minus 12, which is negative 24. So y is negative 24 divided by 8. And that gives negative 3. As usual, when we solve simultaneous equations, we plug our values back into the original two equations and check if they are correct. So if we're saying the solution set is x is 2, y is negative 3, so 6 2 is 12, 8 times negative 3 is negative 24, 12 minus 24 is negative 12. So this one checks out. And negative 5 times 2 is negative 10, minus 3 gives negative 13. So they both check out. So we know that we are correct. So that was our first example. I want you to type and let me know if you get it, if you understand. It's our very first example. We have 7 more examples to work through. I need to know if you get that first one. And if you don't understand, let me know. Where we lost you. So let's go to example 2. So example 2, the set of equations is 3x minus 2y equals negative 10 and 7x plus 2y equals 10. So these are our two original equations. And so what I want to show you for these two is that just looking at the equations, we already see a pair of variables that have the same digits. The coefficients are, the signs are different, but they have the same digits. So when you see that, you can skip the first step that we did. So you can skip this step here, where you had to multiply the equations by the corresponding opposite coefficients. You can skip this step since we already have digits that are the same. We can go to the second step and just decide whether we need to add or subtract to eliminate. So one is a negative 2, one is a positive 2. So remember we said if there are different signs, we add. Same signs, you subtract in order to eliminate. So we're going to add, and always let the examiner know what you're doing. You're adding equation 1 to equation 2. Don't just go and do it and assume that it will be understood what you're doing. Always say, this is what I'm doing right now. So when we add them, we get 3x plus 7x, that's 10x. The negative 2y plus 2y, that eliminates it, which is our objective. That's what we wanted. And negative 10 plus 10, that gives 0. So if 10x is 0, then x is 0. So we have found the value for x. X is 0. So now we can find y. So we're going to substitute 0 for x in either one of the equations. So let's use the second equation. So whichever equation you're using to substitute, write that equation so that the examiner knows what you're doing. So now we're going to put in the value of 0 where x is. So that would be 7 times 0 plus 2y is equal to 10. 7 times 0 is 0. So 0 plus 2y is equal to 10. That means y will be equal to 10 divided by 2, which is 5. So y is equal to 5. So our solution set would be x is 0 and y is 5. And if we plug those in, 3 times 0 is 0, negative 2 times 5 is negative 10. 7 times 0 is 0, 2 5s, positive 10. All right, so that's example 2. So let's proceed. The other example also has coefficients that are the same, but this time the coefficients are both positive. So I want to show you an example of that one. So we have 4x minus 2y is equal to 46. And that's equation 1. And 4x plus 7y is equal to 1. And that's equation 2. All right, so now if you look at the two equations, you see that 4x is in both. So they already have the same terms, same coefficient, same terms. They are both positive, remember. When the signs are the same, both the signs are the same, we're going to subtract. So to eliminate the x variable, we're going to subtract equation 2 from equation 1. So 4x minus 4x, that eliminates the x. Negative 2y minus 7y, that's negative 9y. And 46 minus 1 is 45. So if negative 9y is 45, so y is 45 divided by negative 9, which is negative 5. So if y is negative 5, we're going to plug in that value for y. So let's use the first equation to plug it. So 4x minus 2y. I should have used a simpler equation, but it's okay. Because 46. So 4x. Now we're going to plug in negative 5 where y is. Negative 2 times negative 5 is positive 10. So 4x would be equal to 46 minus 10, which is 36. So if 4x is 36, then x is 36 divided by 4. And that is 9. For example 4, um, 2x plus 3y is negative 10, and 5x minus 8y is 130. So that's equation 1. That's equation 2. All right, so if you notice when you look at these equations now, they are different from the two equations that we just solved, right? In the two last equations that we just saw, we could identify a pair of variables that were either exactly the same or differed just in terms of the signs, but the digits were the same. Here, this is similar to the very first equation that we did, where the variables are just all different. The coefficients are all different. So we're going to go back then to the original strategy, which is to multiply the equations by the opposite variables. So we're going to multiply. So I'm going to choose my x variables to work with, the 2 and the 5. So I'll be multiplying this equation by 5 and this equation by 2. Which means then if I'm multiplying all of these by 5, I'm going to end up with 10x plus 15y equals negative 50. So that's going to be equation 3. And if I'm multiplying all of these by 2, I'm going to have 10x minus 16y equals 260. And that's equation 4. So now, remember, the whole point of doing this is to get some coefficients that are the same or different in terms of signs. So we have achieved that. We now have two 10x's and they're both positive. So remember, we said when they're both positive, we're going to subtract in order to eliminate. So we're going to subtract equation 4 from equation 3. And when we do that, what we're going to end up with, so 10x minus 10x, that eliminate the x. 15 minus negative 16, I believe that would give me 31. And let me see, negative 50 minus 260, so 260. That gives 310. Negative 310. Therefore, y would be negative 310 divided by 31, which is negative 10. All right, so if y is negative 10, so we need to plug that into one of these equations. Anywhere you choose which one you want to work with. So I'm going to work with the first one that has smaller numbers. And I'm going to plug in negative 10 wherever y is. So that means 2x plus 3 times negative 10 is equal to negative 10. So 2x minus 30 is equal to negative 10. So 2x is equal to negative 10 plus 30, which is 20. So if 2x is equal to 20, then clearly x will be equal to 20 divided by 2. So x is 10. So our solution said to be y is negative 10 and x is positive 10. And we are halfway there. Remember, I told you it's eight examples we're working this morning, and we're at just finished example 4. All right, so Ngozi is asking, how did you get 10 from 0 plus 2y? 0 plus 2y, was that from the one before this? Let me check. Which one has 0 plus 2y? Oh, okay, so this one. So the 0, 0 is 0, right? So 2y is equal to 10. Therefore, y is equal to 10 divided by 2. Follow Ngozi? All right, so example 5. negative 3x plus 4y. And that gives negative 9, which is equation 1. Negative 2x minus y is 16. Okay, so just looking at them, we see that all the coefficients are different. All the numbers that are in front of the variable, they're all different. So we're going to go straight to multiplying. So I'm multiplying equation 1, and equation 2 by 4. And that's going to give me, equation 1 will remain the same since I'm multiplying it by 1. So this will become equation 3, same as equation 1. Equation 2 will become, I'm multiplying each of them by 4. So it's going to give me 4 times 16 is 64. So these are my new terms. So now that we have achieved our objective of same coefficient, signs different. One is positive, one is negative. So we're going to add them in order to eliminate. So we're going to add equation 3 and equation 4. So we know that when we add the 4y and the negative 4y, that's going to eliminate. Negative 3x plus negative 8x, that's negative 11x. And negative 9 plus 64, that's going to be 55. So x would be 55 divided by negative 11. And that's going to give negative 5. So we have solved for x. Remember, it's 2 variables. So you can't just solve for one and think that you're done. You have to solve for both of them. So x is negative 5. So let's plug this either here or here. You decide. I'm going to go with equation 2. So that's 2x, negative 2x minus y is 16. And I'm plugging in negative 5 where x is. So negative 2 times negative 5 is positive 10. So negative y is 16 minus 10. So if negative y is 6, if negative y is 6, then it stands to reason that y is negative 6. So what we did was we just divide both sides by negative 1 because we want a positive variable, not a negative variable. So tell me, if you're getting it. Okay. All right. So we're moving along. We have 3 to go, 3 more to go. And number 6. For number 6, the first equation is very simple. It just says negative x plus y is equal to 8. And 3x plus 5y is equal to 32. Now, this would have been a lovely candidate for the elimination, for the substitution method, because remember, I prefer if you use substitution when we have coefficients of 1 or -1. It's very easier, much easier that way. So this would have been a lovely pair to use the substitution, but you can use any method for any pair. Just that some are more conducive to some methods, right? But you can use any method, especially if you are specifically asked to use a particular method. So what I'm going to do is I'm going to work with the y's. So I'm going to multiply the first equation by 5 and the second equation by 1. And that would give me, negative 5x plus 5y. And 5 8 40. And this is our new equation, equation 3. Multiplying equation 2 by 1, I'm going to get the same thing. And already you see that we now have our same coefficients in the 5y. And they are both positive. So we're going to subtract. So we're going to subtract equation 4 from equation 3. You could subtract 3 from 4, It's up to you. You will get some different numbers, but eventually you're going to end up with the same answers. So you are the one who decides which variable you're going to work with first, which set you're going to multiply by what, which one you want to eliminate, all up to you. You could take 3 from 4, 4 from 3. It really doesn't matter in the end. So if I'm taking equation 4 from equation 3, it will be negative 5x minus 3x. So that's going to give me negative 8x. And I know that the 5y minus 5y eliminates the y, which was my objective from day 1. And 40 minus 32 gives 8. So if negative 8x is 8, so x would be 8 divided by negative 8. So x is -1. And I would plug that value now. I'm going to choose the first equation. So negative x plus y is equal to 8. So if x is -1, that means negative times -1, which is +1. So 1 plus y is equal to 8. Therefore, y is equal to 8 minus 1, which is 7. And always plug in your values to check, right? So we're saying for our solution set, x is -1 and y is 7. Anytime you're solving a pair of simultaneous equations, or even if you're just solving one equation, whether it's a linear equation, a quadratic equation, or any other type, when you get your solution or solutions, plug them back into the original equation and check if it adds up. If it doesn't give you the same answer, then that will indicate to you that at some point along the way, you made an error, you did some miscalculation. So you need to go back and check. Your solution should plug back into the original equation and give you the answer that was there. It should add up, it should make sense. So 2 to go. So we're making good time. We're making good time. Number 7. So number 7 says -3x minus 2y and that is equal to -20. And I like to number my equations so that when I'm writing, I can let the examiner know I'm working with equation 1, I'm working with equation 2, because you need to communicate with the examiner. Let him or her know what it is you're doing. Don't assume that people understand what you're doing. Don't take it for granted. Say, this is what I am doing. If you're using a particular formula, say, this is the formula I'm using. Write out the formula. Don't think people can read your mind. So looking at these two pairs of equation, or this one pair of equation, so the coefficients are all different. I'm going to work with the 3 and the 5. I'm going to multiply equation 1 by 5 and equation 2 by 3. I remember I tell you that some teachers will say use a sign with it. For me, it makes no difference, since we're still going to end up with having to see when we get to the next stage, do we add or subtract? So for me, at this stage, I'm just working with coefficients. Some of you, your teacher might specifically say use the sign. So for example, you'll be multiplying equation 1 by 5, equation 2 by -3. You're still going to end up with a set of equations that going to have some numbers negative, some positive, and you're going to have to decide, do I add or subtract? So for me, it makes no difference really at this point. So if I'm multiplying all the terms in equation 1 by 5, I'm going to end up with -15x minus 10y is equal to -100. And that's my new equation, equation 3. If I'm multiplying all the terms in equation 2 by 3, I'm going to have 15x plus 18y. And 3 4s 12, 132. So what I end up with here is that one of the is a -15x and a +15x. So I know I need to add them in order to eliminate them. If I add a negative and a positive, I get 0 once the digits are the same, which is what I want. I want to eliminate it. I want it to be 0 so I can focus on the other term. So when I add the two equations, that gives 0. Negative 10y plus 18y will give a positive 8y. And negative 100 plus 132 I believe that's going to give 32. So 8y is equal to 32. Therefore, y is equal to 32 divided by 8. So y is 4. So we can plug 4 where y is in any of the two equations. Just make sure to state which one you're using. I'm going to go with the positives because it's easier to work with positive numbers for most persons. So I'm choosing equation 2, and I'm going to plug in 4 wherever I see y. So that would mean 5x plus 6 times 4, and 6 fours are 24. So 5x plus 24. And this is just regular solving algebraic equations from here, right? Ultimately, we want the variable by itself, so we are moving everything else to the next side by doing the opposite operation. So 5x is equal to 20. Therefore, x is equal to 20 divided by 5, which gives us 4. So our solution set, they are both equal to 4. X is 4, y is 4. And that is perfectly allowed. It's perfectly fine for your variables to be equal to the same thing, right? It just boils down to what your equations are and what you get. So we have one equation to go. And so that's number 8. Always remember, if you have questions, post your questions. If you want to work them as we go along and post your answers, that's fine as well. So you can know, and if you're just working in your notebook, work it and see if you get the same answer. So let's do the last one. Okay, so number 10. We have 5x plus 2y is equal to 33. And x minus 3y is equal to 27. None of the coefficients is the same as the other. So I'm going to multiply equation 1 by 1 and equation 2 by 5. So equation 1 will remain the same. Oh, I have number 10. This should be number 8, right? That's number 8. So equation 1 will remain the same because I'm multiplying it by 1. Equation 2 will become 5x minus 15y. 5 7s 35, 5 2s 10 and 3 13. All right, so now that I have same coefficients and they're both positive, I'm going to subtract. So I'm going to subtract. This time I'm going to take equation 3 from equation 4, and I'm doing that because this number is bigger than that one. But you could have worked it the other way, just that you would end up with a negative number, but that's fine. So that from that is 0. So it will be negative 15y minus 2y, which is negative 17y. And 135 minus 33, that's 102, I think. Let me double check. So it's 135 minus 33. I said 102 and I wrote 104. So I'm saying one thing and writing another thing. So y then would be equal to 102 divided by 17. And I believe that is, oh, it's negative 17, by the way. So that's negative 6. So if y is negative 6, we're going to plug that here. So this is the equation I'm using for the second part. So write the equation that you're using. Don't just go so bam and you see all kind of things working out. Write the original equation that you're using. So we're going to plug in negative 6 where y is. So we're going to have x minus 3 times negative 6 is equal to 27. So x, negative 3 times negative 6 is a positive 18. And so x will be equal to 27 minus 18, which is 9. So the solution set, x is 9 and y is negative 6. And that's it. We've done eight sample questions. So to recap, this particular method of solving simultaneous equations, this algebraic method, is the elimination method. And we call it the elimination method because we eliminate one variable so we can focus on the other variable to solve it. And then we go back and fetch the eliminated variable to solve for that, right? To eliminate means to get rid of, to cancel it out, to ignore it for a while. So that's why we call this method the elimination method. And it's all up to you. It's up to you which of the variables you're going to focus on and which one you're going to eliminate. And remember, the variables don't always have to be X and Y. It can be any symbol, any letter, any symbol. Don't be put off if you see W, V, X, Z, P, Q. Work it the same way. You're going to be given two equations with two variables. Line them up. Make sure they're in that order first. One variable, another variable equal to a whole number. Line up the other one just like that. If you are given the equations and they're not in that form, you have to put them in that form before you can use the method to solve them. So make sure they line up. And then you decide which coefficient you're going to use, which pair you're going to use to multiply one equation by the next. You decide which equation you're going to take from the other, or whether 3 from 4, 4 from 3. You're going to end up with different numbers in the middle, but ultimately your answer will be the same. So it really doesn't matter, and it's all up to you. You have to look at the equations and see how you're going to manipulate them. So for example, the equations that have positive numbers, you might want to work with that equation. Most people are more comfortable working with positive numbers. You might choose the equation that has smaller numbers to work with. Most people are more comfortable working with smaller numbers. Also, look out for fractions, look out for decimals. Don't be scared. Work it same way. I know you know how to work fractions and decimal. So if you see a decimal or a fraction in the equation, just do what you need to do. If you have to go to the side and work out the fraction part, go and do it. Don't be turned off because you see a fraction there. Same principle applies. So that's it. Those are our 9 examples, and I hope that you understand now how to work simultaneous equations, how to solve them using the method of elimination.